Just before we start, I'd like to take a quick poll here just to understand kind of the audience range here from who's been in the IoT industry for more than 15 years? Okay, a few. More than between 10 and 15? Okay, so we have a lot of newcomers to the stage here. I like to reflect on a little history because I always like to benchmark where our industry is at. And LoRaWAN is a subset of a much broader industry. So the early days of IoT was a lot of hype. And hype, there was a lot of projections, a lot of predictions as far as what the scale of IoT could be. And the most retold stories of our projections were from the leadership from Cisco and Ericsson, where they projected that by 2020, we'd see 50 billion connected devices. Now, the US government also cited a report in 2013 report that stated they thought 25 to 50 billion connected devices by 2025. So not quite as aggressive on the timeline. So the question becomes, where are we? What have we achieved up to this point as an industry? Do we want to guess? Who says more than 50 billion? 25 to 50 billion? Less than 15 billion. Okay? The real answer is somewhere in between there. It's, according to IoT Analytics in their State of IoT report, they suggested that there was 18.5 billion connected devices at the end of 2024, and they projected that the end of 2025 would be 21.1 billion. I don't know what the numbers are really today, but that's a good 14% growth year over year on connectivity. And as you can see, if you look at LoRaWAN, we're starting to scale much more aggressively today. We represent a 25% year over year growth, so we're starting to see some of the changes happening in our space as well. Okay, so the question we have to ask ourselves in this context is, are we underachieving? Did we underachieve as an industry? And maybe the better question would be, were the projections a little bit overambitious? Or did we really underestimate the challenges related to scale of IoT? So good morning, everyone. My name is Duane Wald, and I have the distinct honor and pleasure of being the Chief Product Officer of MultiTech Systems. MultiTech is a global provider of industrial IoT connectivity solutions. We are a founding member of the LoRa Alliance, and our focus is on the real-world challenges of connecting assets reliably, securely, and at scale. We have a portfolio of LoRaWAN gateways, LoRaWAN sensors, and other wireless technologies in our portfolio. So I posit that we actually underachieved as an industry. I think we underestimated the challenges of IoT. We certainly have faced a lot more challenges in scaling LoRaWAN in IoT than probably early projections predicted we would have. So what I do also understand is that, well, let's talk a little bit about LoRaWAN first. I want to level set on the LoRaWAN, what it is. So LoRaWAN is a leading wireless standard for low power wide area networking. It is purpose-built for IoT and massive scale device deployment. Its characteristics are that it enables devices to transmit small amounts of data over very long distances while consuming extremely low power. Unlike Wi-Fi and cellular, again, LoRaWAN was purpose-built for sensors that need to operate for over years on battery power. So that being said, we did underestimate the IoT task, the challenge of IoT at scale. I think we need to address that today. One of the things that we recognize that connectivity is not an issue, scalability is an issue. The biggest challenge in IoT is not connectivity, it's scalability. And when I talk about scale, I'm not talking about just more devices. It's repeatability and predictability of deployments. And when we talk about repeatability and predictability, it requires business process automation. Scale means integration of systems. It means managing devices over long life cycles. That's the real true scalability in context of IoT. And if you look at this chart, it's not necessarily a vendor problem. It's not a system integration problem, but it does represent an ecosystem opportunity. I think that the ecosystem has to come together from a collaboration standpoint from device manufacturers to system integrators to network providers, platform vendors, and customers, they all have to start operating off a common architectural foundation. And when those pieces align, scale becomes predictable, repeatable, and more importantly, economically viable. So let's talk about some of the real-world lessons based upon that. One of the things we also understand is that organizations in the real-world deployments that succeed at scale, they also look at IoT they look at IoT as an ecosystem strategy. Those are the ones that are successful. So one of the things that we recognize also is that hardware is not necessarily, in and by itself, is not necessarily a bottleneck in our world. But scaling physical deployments becomes very complicated and offers a lot of challenges regarding predictability and repeatability. We have one client that is deploying a really large-scale network, thousands of gateways, hundreds of thousands of devices, and they presented us with the challenge of no less than 18 process steps they go through from procurement to deployment of their IoT system, from a gateway deployment or a device deployment. So we worked with them in the ecosystem around that solution to reduce that to way less than 50% of those process steps. We're down to less than 5 steps now. That's the capability that is out there. That's what we need to accomplish as an ecosystem and as a vendor chain to really drive the pre-provisioning, the automation, the business process automation, the integration with systems, and working with the vendors to automate a lot of different parts of the deployment and management of an IoT system. The second challenge lesson we ran into was that a one-size-fits-all will lead to dissatisfaction, will lead to disappointment, because there's no one way that an IoT can be deployed on a global scale. So we work with a number of different wireless technologies, and it's really about fit for purpose. You look at wireless is not a technical specification in context of IoT. It has to be a business enabler. So regardless of so your architectural foundation of the solution has to have some flexibility to address some of the challenges related to where you're deploying, the deployment types, and regional differences. And third is the total cost of ownership. It doesn't end at the procurement of a device. Total cost of ownership is going to continue to contribute to the cost over many years. And so it's important from a standpoint of integrating with software it's got built around long life cycle capabilities to manage devices, manage networks, manage your fleets, et cetera. So the ecosystem has to come together, continue to innovate in this area, and we have, to really produce software that really sustains systems and IoT systems worldwide, globally. So now I'm going to talk a little bit about a couple different use cases. Water damage is probably the most expensive and most common insurance claim in the market today. Here's a challenge that came out. We have in Chicago, there's 245-story high-rises, luxury apartments, and they had a problem with their HVAC system leaked. And this occurred over not just an event, but occurred over many days, months, and they had a very catastrophic financial loss in the system. They got together and they wanted to address that particular use case and try to add that into the building management system to prevent it in the future. So we have a smart building initiative in the company, and we've done some integrations with the building management system companies to integrate LoRaWAN sensing into building management solutions. And so when we worked with the integrator, they were quickly able to validate a leak detect solution using LoRaWAN and apply it into this particular situation. What's interesting about this is that the system integrator now has a repeatable and scalable solution that they can apply to any commercial and residential property for leak detection. That's the type of integrations and type of collaboration that can enable scale in IoT, in LoRaWAN IoT. This use case is a little bit differently. It represents a food safety compliance. Not only applies into, it really has a category of cold chain. It applies to quick serve restaurants. It applies to grocery stores and chains and retail chains. This particular customer had 15,000 stores globally. They had in a fuel and convenience store chain. They wanted network at each location. They wanted centralized data, and they wanted centralized management of the network. So we worked with the solution provider, and they took advantage of our gateway. It's got a level of intelligence in it, and they were able to integrate the gateway and the LoRaWAN sensing directly into their business application. And they've been rolling this out globally now for quite some time. So we've got thousands of gateways, tens of thousands of sensors handling food safety within this particular customer. So the good news is IoT is scaling now. We're now contributing much more significantly to it, and we will continue to contribute. I think it's gonna scale. I think our percentage of year over year should scale. We're seeing a lot of good traction in the marketplace today. And new technologies are gonna continue to increase the momentum and the opportunity and the innovation in IoT. In 2026, you'll see LoRaWAN as a viable solution for indoor tracking as a means of married up with other wireless technologies such as Bluetooth. We will see additional opportunities where we can integrate other legacy protocols with LoRaWAN through a smart gateway strategy. So this is happening now. And I think that the maturity is here today. I think the ecosystem now is responding, is collaborating quite well together to actually drive more scale in IoT. So just to conclude, I'm not quite sure how I'm doing on time or not, but we're connecting the physical world around us today. I think we've addressed a lot of the issues with the early days of LoRaWAN and scalability. MultiTech and the LoRaWAN ecosystem and other ecosystems are coming together to not make IoT at scale only possible, but we need to make it practical. So with that, I'm gonna stop. Thank you for your time. Appreciate you coming out here. We're on the LoRa Alliance booth, so come visit MultiTech and see what we're doing. I will stick around for after the session here if you want to have a chat. But I appreciate you attending this session. Thank you very much. Enjoy the week here at CES.
I thought I was going to have to catch him. Good afternoon, everybody. Wake up. Look at you out here. There's two of us up here. We're going to talk about practical applications. And Rob, go ahead and introduce yourself.
Sure. Hi, I'm Rob Zagarella. I'm the founder and CEO of NNNCo and NXN company. I've been involved with emerging technologies within the utility sector for the last 25 years, and I'm also on the board of the LoRaWAN Alliance.
I'm Rich Sanders. I'm president of Zenner USA. Zenner globally is the largest water meter and gas meter manufacturer in the world, and we use many connectivity technologies. We've been a member of the Alliance since the beginning. I also sit on the board, and what we're going to focus on, Rob and I, is giving you practical applications and the typical return on investment the industries are seeing from us using LoRaWAN to handle their needs.
Okay, so what I'm going to talk about is how we've used LoRa technology and the LoRa protocol combined with a rich ecosystem of devices and solutions to solve problems and challenges within the energy sector. And specifically the electricity distribution infrastructure, the infrastructure that drives a lot of the energy consumed by all of us, every residential and commercial customer around the world. And how did we do that? We actually sat down with the largest electricity distributor in the UK that serves over 8 million connections. And how did we do that? We actually sat down, big ears, small mouth, and we listened. We listened to the challenges, we listened to the problems, and we found solutions. And what I'm going to do is take you all on a journey over the next few minutes about what we found, why it was important, and why it's actually important for all of us here today. Sound good? Yeah. Fair enough? Okay, let's go. So firstly, a little bit of a backdrop, a little bit about the energy industry. Back 25, 30 years ago, it was a one-way system. Right, you would generate electricity, we transport it over vast distances at hundreds of thousands of volts, and then it gets delivered through large transformer infrastructures into the power points that we see here today, 110 volts here, 220 volts in the UK. But what we're finding now is we've got two-way flow of energy. because we're trying to drive a sustainable net zero future. So we've got two things that are impacting that. We've got solar panels on residential homes, and users are being driven to sell excess solar back into the grid. And then we've got vehicle to grid, the proliferation of electric vehicles, and selling that back into the grid as a battery storage device. All of that has to flow through the existing infrastructure. And these are assets that have 30, 40, 50-year life cycles. You've got an aging workforce. So you've got a big challenge to solve. So what we found is that there's really 4 key sort of litmus tests that we need to get through in order to be able to apply technology and IoT solutions for electricity distribution infrastructure. It's got to improve reliability. You've got to keep the lights on. Every second that the light's off has a business value attached to it. It's got to drive safety. People die for managing and operating electricity at hundreds of thousands of volts. Even some consumers die each year, and we're going to talk a little bit about that. And it has to improve customer service. So the requirements from a customer on their energy source, think about a NVIDIA server farm and the requirements that they have on their energy provider is vastly different from 30, 40 years ago, putting a kettle on the stove. And of course, we're talking about scale. Hundreds of thousands of assets that need to be monitored. So it's got to be cost efficient to be able to get through a business case and really add value. So what did we find? We found 3 key pain points that we attempted to and successfully solved. And it actually turned out to be part of then a blueprint of how to actually leverage IoT for the energy sector. One was what's called high voltage conductor down. So think about those tens of thousands of volts along power poles in the urban and rural areas. Sometimes they break, fall on the ground, and they're actually live, and the control room can't detect it, and there's very technical reasons as to why that I won't bore you with. But that just is the case. So we applied a technology called the Power Pilot. It's on display at the stand, next to Rich's stand on the LoRa Alliance, where we're able to apply a low-cost method of monitoring low voltage on that pole to be able, and using AI and machine learning and detecting in real time what's happening on the high voltage network, and we solved that problem. Then those high voltage connections of tens of thousands of volts come together in a termination point when you're moving more into the urban infrastructure and you're driving the power underground to serve an underground reticulation network. Those connections degrade over time and end up with catastrophic failures, burnouts and blowouts, resulting in thousands of customers that are out of power. So we're able to actually innovate and develop a sensor using LoRa technology that could be mounted a distance away from that connection, and we could listen using ultrasound technology for that degradation over time using partial discharge, which becomes an early warning of failure for that termination point. And that was successful and a world first. Then when you get into more of the city urban areas, you're walking along the sidewalk and you'll see the lid with the electricity name on it, and you've got underground low voltage, a couple of 100 volts, that the utility uses to switch and control and manage the underground network. That's a hostile environment. Sometimes you get gas leakages in there. When faults occur at the same time, those lids can explode and cause issues with residences on the street. That's a reality. So they wanted a solution to be able to actually monitor the environmental conditions within that environment, which is so challenging. How do you get an RF radio frequency signal from a telco carrier grade infrastructure miles away into that concrete steel reinforced lid, into an iron 30 kilogram bell cover, and into the actual sensor and device itself? And we managed to achieve that successfully. So what did we find? What was some of the key takeaways here? One of the key important takeaways is that working with the field crews, the lines people, they used to call them linesmen, but they're lines women, so it's lines people, that are actually managing and operating that infrastructure and making sure that it's not just about throwing another sensor and throwing another device in the field, and Duane alluded to that. It's about making sure that it doesn't drive an additional operational burden for the field staff. So in the case of when we deployed that little black box on that high voltage pole monitoring the low voltage, by installing it one pole down from the transformer, they were able to install it with less safety requirements, so a cheaper install, a safer install, and installing it without actually turning the power off, which is going to cause an outage, which has an economic benefit, economic disincentive. In the case of the partial discharge sensor, we were able to install it within 1.5 metres from that 11,000 volt connection, which means that it met the safety guidelines of being able to be within 1.5 metres from an 11,000 volt connection within 15 minutes without having to turn the power off. So it was a massive lesson learnt. And then in the case of the underground link box, it was the fact that we were able, as the world's first with the LoRa technology, get a reliable signal into that underground infrastructure. And what we learnt from that was the opportunity of now being able to provide connectivity in underground assets, and that opens up so many other opportunities for monitoring other various important assets. So really what it's about is to drive actionable intelligence at scale involves knowing where the intelligence needs to be deployed without resulting in an operational burden for that infrastructure, improving safety, improving efficiency, and improving resilience. Now, to do that, to actually make that happen in the real world, it's about getting the data together in a centralized platform, being able to normalize that data from a whole raft of sensors and devices. If you go downstairs into the LoRa Alliance stand, you'll see hundreds of different sensors and devices. It's a real power of LoRaWAN is the ecosystem. So we have a platform that can bring all of that data in, non-vendor specific, into a platform. And then when we look at IoT from an end-to-end perspective, we have to take that data and integrate it into the business as usual systems that are managing and operating that infrastructure today. In the case of electricity infrastructures, there's systems like GE, which has a SCADA system that's used throughout the US, throughout the UK. So we have a productized integration into that platform. So we can drive value from existing sensors and devices and new sensors and devices that appear in the future. Thanks very much. I hope that was interesting.
That's it?
That's
well,
it.
let me add a couple things that Rob did a great job. Now let me give you a couple data points on why you should care. Maybe you don't care about anything about electricity, but how many people here use electricity? Everybody, right? How many? No, some of you guys didn't raise your hand, so I guess you don't. You live in one of those places where you. What people don't understand is what it takes to bring power to your home, right? The conversion of power. You hear a lot about pollution. You hear a lot about power plants. The best combined cycle plant in the world, by the time those kilowatts come across all those lines, all those transformers, is about 54% efficient when it reaches your destination. What does that mean? You're about 5% better than your car, because your internal combustion engine today runs at about 49% energy conversion. For those who don't understand energy conversion, it's kilowatts in of energy versus kilowatts out of energy. So why is it important what he's talking about? Because he's going to detect issues within the grid, and if you could just save 10% of all the energy in the world, that's a significant amount by managing and monitoring those points and knowing when you're getting those losses there. And I'll move into water. I'm going to be talking about water here in a second. You know, our critical resources, electric and water, are extremely important. How many people here know that in the next 10 years, the demand for kilowatt power in the world will double? How many here knew that? Yep, just one person. Yeah, it's an unbelievable amount. It needs to fund all, you hear a lot about AI. Everybody here has heard about AI, right? Got all these robots walking around out here. So AI draws a lot of power. That power, these AI centers need to have a lot of cooling, a lot of power. A lot of that power will be on site. A lot of what Rob's talking about can also be used on site to make sure energy conversion on site can be as high as 94%. Huge difference. So I'm going to move on now to water. So in the water industry, everybody knows, how many people here know that globally that we're running out of water in lots of places, right? Yeah, it's critical, right? Colorado River doesn't reach the ocean anymore, right? And everybody hears about that, but it's critical. We're using our water up. It's not a renewable resource in the sense that we get some rain, but also it also affects our climate because we don't get as much rain today because we don't have as much evaporation, therefore we don't get as much rain, which is what cools the earth, so we are a little warmer. So from a Zenner standpoint, and I'll tell you a little bit about Zenner, and you missed that slide. If you go back one. So Zenner, we've been around for 122 years, and we've been in this consumption-based data management business for a very long time. And what we want to give our customers is the ability, right, with technology to manage their resources. It's critical. Water loss in the United States, across the United States, from the time we treat it, put it down the lines, and it gets to a customer, we're losing about 35% of that water. It's a huge, huge amount of water. So technology is the only way for them to control it. Zenner has been a user of the LoRaWAN technology. So why do we choose LoRaWAN? Well, I don't know what the sessions before me told you, but LoRaWAN is a modulation, we use a modulation scheme from Semtech. So you take a typical message that we send in our old devices, about 360 bits of information, and we now shrink that down because of the LoRa Alliance creating their technology and Semtech creating the chip to about 30 to 40 bits of information. And what that means is I can travel further, significantly further than I have before with my data. Because the smaller the message, the longer the distance it can travel, right? So we'll move, so we've been around, we have about 11 million LoRaWAN devices distributed in our networks so far. And we'll move on from that, go to the next one. Why are people interested, right? Well, how many here invest in things based on return on investment, right? Somebody you buy an air conditioner for your house, they tell you on how many years it's going to take for you to get that money back that you just invested in buying that new air conditioner. Why? Because you're conserving power, right? So everything we do in our life, not really, because we're human beings, so we're emotional, right? Especially, well, I won't say it. My wife's very, they go out shopping and they get emotional, they buy things. I'm less emotional about buying things, but everybody buys a car, right? Everybody can use a low-end Kia, but instead they buy Cadillacs and Mercedes and because they're emotional about their buy. So what we do is you got to explain to people why you get a return on your investment. And this is a typical return on investment. When we automate a utility, right? And that utility can be a small one with 3,000 water meters, but over 400 square miles, right? And they need to read those meters. And then they need to manage their line losses. We can do that. Typical ROI is 2 to 4 years on a system with LoRaWAN because we have less infrastructure that we need to run that network. So be aware that this utility happened to be in a ski area, and we were able to get actually about a 1-year return on investment here, as you can see the numbers. So everything is based on return on investment and net present value. Everybody understand net present value? Yes? No? Communities. So net present value is once you pay off your investment and that item still runs for a number of years, the money you accumulate, right? Because you've already paid your system off, is called your free cash flow. And cities look for that free cash flow. So almost every city in the world is looking at some sort of automation. What the LoRa Alliance has done, and this is extremely important, because when you go to a city, they got a system for lighting, right? And they hang their collectors all up, and they got a system that controls lighting. They got one that do their water management on. They got systems that do just air conditioning. LoRa Alliance, an open standard, gives a city the ability, right, to put one system up and run all their needs. The LoRa, if you don't understand, I don't know what they explained to you before, but if you don't understand how a LoRa network server operates, it's basically a traffic cop. So if you have several different vendors, if Rob's running his stuff through my server, we can still direct that information directly to him, and he can display it for the customer. It's really unique. If you don't understand how many people here are developers? Any developers in the room? Developers. How many here are manufacturers? Any manufacturers in the room? Everybody should look into this because the LoRa Alliance gives you the ability to very quickly develop a product, put it on a marketplace, and people like myself, right, and Rob, we partner with each other to move products through our networks because it works easily with our networks. We don't have to do anything else. We know you developed your product to an open standard, and that's what works. Move on to the next slide. Now let's talk about the different types of communication. You know, we have RF, line of sight communication, you know, cities use. They have mesh networks, cellular, right? The very expensive cellular networks dependent on tower coverage, PLC, power line communication. Each one of those has a downfall. The issues are coverage gaps in rural areas, infrastructure dependency, and of course, vulnerability to outages with that network. So what's coming next, right? Everybody knows this, right? Because you're all using it in one form or another. We have satellite coming, right? It won't be long before almost everything is on satellites. There are 1,000 satellites a year being launched. You have fixed orbit satellites and you have low orbiting satellites. And they're all being launched. And they're not very big, by the way. They're a little bit bigger. The low orbiting satellites, a little bit bigger than your chair. They launch about, you know, Elon's got it down to a science, so we'll get 15 on a little rocket and drop them off. And so what does that mean to you? It means costs are coming down. Everybody thinks of satellite communication as high cost. It's not. You can go down to Costco, right? Buy yourself a Starlink pack, go to the middle of the Sahara Desert, and you can watch Netflix for about 120 bucks. It's amazing. So what makes satellite important to us is with LoRaWAN, I can actually go straight up 27,000 miles and down in 30 seconds with my information. And then I have no lapse of coverage. Satellites have no lapse of coverage. You're going to cover all the rural areas. It won't be long before the whole globe is covered with satellites and you got complete coverage. Low cost. It's going to be about 25% of what cellular costs today. So keep in mind that technology advances don't always cost more. You're about to see, in my opinion, right, a shift, a very dramatic shift in technology, not only with AI, but I think with satellite technology and the low-cost usage of it, because there's so much bandwidth to use and very dependable. So again, if you're looking at a land-based LoRaWAN system, if you're inside a very dense city, you're talking about 2 to 3 miles in range from a collector to a device. If you're talking about, you know, rural areas, we can get up to about 15 miles. In fact, 15 miles in very noisy environments. One of the other wonderful things about the LoRaWAN product is it avoids a lot of noise. How many people understand messaging? How many people here ever saw the Matrix? Really, Matrix? Remember when Neo saw all those zeros and ones, right? It was all crowded. That's what this room would look like if we could see all the data flowing through here right now. That's called noise level, right? And then when a message hits another message that is stronger, it destroys it. So that finishes its distance, right? Its integrity. So the key is to be small. How many people here have ever played Frogger? I'm an old guy. You know, I was around when Pong was being played. So anybody here ever play Frogger? The little frogs, easier to get across there. The bigger frog gets run over all the time. Bigger messages are always getting run over. So that same sort of principle. So keep that in mind. Again, if you have a little interest, if you're a developer or a manufacturer or somebody just has a need, come over to the LoRaWAN booth, talk to us. We're not there to really sell you anything. We're there to give you information. So please feel free to come by. Are there any questions or anything from anybody for Rob or I? No? We've done a good job, or you're totally bored and you want to get out of here. Which is it? Huh? Which hall are you? We're right downstairs. The hall is, help me out here. I'm sorry, what was it? I couldn't hear it. 10349. That's right downstairs. It's not a long walk. Huh? Yeah.
Yeah. Look for the big yellow LoRaWAN sign. You'll see it up.
Yeah, and look for us. 2 handsome guys standing in the booth down there.
Come on.
We'll be there.
Come on.
So if there's any questions, please come down and talk to us. We're happy to answer any questions. And developers, if you're looking to maybe jump on the bandwagon and get into the LoRaWAN development, wonderful organization. It's, you join it for a couple $1,000 and you're getting all your technology for free. So, all right, thank you.
Thank you, Rich and Rob, for demonstrating how LoRaWAN empowers utility networks for saving planet's resources, for saving lives, and also improving business efficiency. So we have celebrated our first decade, and we keep moving forward. And what is driving us forward? It is our ambitious vision that LoRaWAN will become itself a global utility. It'll be ubiquitously available through multiple types of networks integrated together, serving the end devices. And it'll also be truly plug and play. As such, it'll provide base connectivity for anything that is digitalized. It'll also accelerate digitalization of objects. And it'll be forming the digital nervous system of the planet, complementing the digital brain, the AI. As such, it'll be touching every business for improving efficiency, every person for improving quality of life, and every part of the planet for protection of our planet. LoRaWAN is already rising as the fourth pillar of the wireless communication industry, complementing Wi-Fi, Bluetooth, and cellular technologies. And what is behind all that vision, the implementation, is our LoRa Alliance ecosystem. This is the core LoRaWAN ecosystem. We have more than 360 members in the LoRa Alliance, and in 2025, we have added roughly 60 new members. And these members are from all around the world, from Americas to Europe, to Asia, to Middle East, to Australia and New Zealand. And they cover the full ecosystem, from chip makers, module, device, gateway, core network, system integrators, operators, enterprises. And what draws them to join the LoRa Alliance is starting from, all the way from steering the technology through contributions, discussions, voting, to certifying the end devices, running interrupts, and using the LoRa Alliance expertise and also facilities like network addresses and vendor IDs, things like that, for getting the products and services ready for scale. And finally, we support marketing our members' products and services through events, webinars, our successor database, publications, social media. And it's not a surprise that world's largest LoRaWAN deployments are operated by LoRa Alliance members. And it'll always be the case as we keep scaling forward. LoRa Alliance members will be in the best position to take full advantage of this technology. With that, we conclude our morning. We all hope you have enjoyed this session. Like my colleagues have mentioned, please do come and visit us. We have a pavilion. 14 of our members are exhibiting numerous applications using Edge AI, energy harvesting, tracking, smart buildings, satellite-connected meters. We are in this hall downstairs at hall 10349. Also, very welcome to join the LoRa Alliance, join the journey, and have a great rest of the day. Thank you for coming.